Hi everyone, I hope you can hear us. You can hear us definitely, I guess so. If not, I don't know what to do. You need to know it. I hope you can hear us too. If not, please just text us and we'll make sure we improve that. Yeah, I'm really happy to be here. Our second meetup after the whole COVID situation is still ongoing, I guess. So we're having driving developer experience with Kubernetes Operators. I'm really happy that you joined us today, David, and your colleague. Thanks a lot. Really looking forward to it. And if you remember 2 years ago, something like, no, 3 years ago, we had a thing that was called Open News, and you have to help me now to find it. Yeah, thanks a lot. And what we did is we just discussed news. About Kubernetes, CNCF, and so on. So is there anything that you think is shareable or interesting to share regarding cloud native computing or cloud native application development? If not, I have some ideas, I have to admit. But so one thing that drove me really sad is that Kubelist is now a podcast. So nothing anymore to read since June. I'm really sad about that. I read it every week. I don't know if any one of you knew. However, there's a new weekly from the CNCF. So we can switch there. Maybe that was the reason they stopped.
There's a new weekly from CNCF?
Yes, regarding Kubernetes.
Okay.
Oh, by the way, CNCF, we are back in Amsterdam next year. And the CFP is open, so if you want to, for example, submit this as a paper today, let's go. I think it opened today. Yeah. Let's do this. Amsterdam.
Cool.
Is CNCF Europe launched, right?
Yeah, CNCF Europe next year.
Yeah, but CNCF Europe as a subsidiary now launched, right? From the, I guess, actual...
Oh, really? I didn't know that. CNCF Europe as a subsidiary?
Yeah, I
okay.
don't know like what they're focusing on now. Like they just, I think, announced it like 2 weeks ago or something. They sent it out.
Okay, interesting.
Yeah, like pretending to be focused. I guess it's ML topics that they're focusing on. Yeah.
Cool.
Oh, and something else I read yesterday. The Azure CTO now says that stop coding C and C++, just use Rust.
Yeah.
I think that's an interesting message. I love it. What do you think? What do you say?
I think
can you code in Rust?
I've did it a while ago. Yeah.
Oh, really? Cool.
Never went deep into it. I then went more the Go direction. But I think the interesting part of this tweet is he says this for security reasons, right? Mm. And he actually even says that all these non-garbage collected languages like C++ and C should be treated as legacy, right? I think that's what made the waves on Twitter and where people were complaining. But I personally think he's right, yeah.
Linux 6.1 also contains Rust now, no? Like
which one? What the?
Linux 6.1 now.
Exactly.
Oh yeah.
Yeah.
But for drivers only, right? Linux 6.1 for drivers only, Rust possibilities.
Should we repeat the news from the audience?
I think so, yeah. That's why I did it. Yeah.
So Linux 6.1 includes Rust now for drivers. I think that's a big thing, yeah. And I think the second big thing for Rust is the good WebAssembly support, right?
Good what support? Sorry.
WebAssembly support.
Oh, WebAssembly support, yeah.
They were the first ones who could compile directly to WebAssembly, I guess. Right?
Oh, and do you know REFL?
Yeah.
So if you want to still run your Flash application in the web, you can use refl.rs. Oh, and there was another thing regarding WebAssembly. I think it's called Start Assembly or something like that.
Okay, no.
Sorry, I don't remember on the top of my head, but so if it's a WebAssembly sandbox you can also use at Kubernetes.
Okay.
In Kubernetes, I think it's called Start Assembly, but I will look it up and write it in the chat afterwards.
Yeah, I think WebAssembly has the I would say maybe the power to replace, lots of kind of I would say container standards we use this day as the new kind of common interface for applications, right? I think that's the big bet on this. Any other news from the audience? I have one which I would like to share with you, but because I'm so proud that I finally did it. I guess everybody knows Kubernetes the hard way from Kelsey Hightower. And I locked myself in over the weekend and finally went the hard way. And I really learned a lot again. It's really, I can fully recommend this. If you didn't do it so far, and if you already work with Kubernetes, have some experience, it's still something which I guess at some point in time everybody needs to do, right? To really, it's not just a click on the cloud, right? In the background, it's very interesting to see what's happening, yeah.
Maybe something more.
Yeah.
I mean, there's a cool project. I mean, I think it was 1 or 2 weeks ago. There was Container Days by a former employee of mine, Geomatica, called in Hamburg, and there was a cool talk by Stefan Szymanski and Sebastian Scheele about KCP. It's a project. They kind of, I think they have some changes towards the API server itself that basically removes the out-of-the-box machinery that comes with Kubernetes, right? So it removes deployment, stateful sets, all of this stuff, except custom resource definitions and some other additional resources that you need, like leases and so on. So you basically have like an empty kind of like bare bones API server, right?
That's interesting, because this fits perfectly to this
that's
talk.
why I thought that maybe it fits here. And they also they add this concept. So I had like a quick talk with them. I think it was a super cool concept, which I also like. I use a lot of API servers, never actually touched out-of-box resources, and they actually add a lot of ideas about how like multi-cluster or service providing across classes could work within like a standard API. So they have a couple of patches in the KCP project. I think it's KCP Dev on GitHub. I think it's super interesting to check out. You're providing like custom resources within like an API server and another API where you can basically register another cluster as a service provider, and you can kind of like sync that to another cluster.
Okay, interesting. So KCP was called, right?
It's called KCP, and I think it's kind of like taking this this service catalog concept which existed kind of before everybody started using custom resources and so on. Kind of like revitalizing that in my opinion, and kind of making into like being native types rather than just like a generic service instance kind of instantiation of something else. So like you have native custom resources you can actually work with, you can interpret marshal and marshal.
So do you think that we will have then forks of Kubernetes in the future where people implement different, I don't know, different concepts like pods, you know?
I mean, I don't think it should be the case. Like, I mean, there should be a proper upstream, downstream relation, right? But I think it's more kind of the idea to just showcase what could be possible, and the idea is really to eventually merge it back into Kubernetes. So it's not to like really create a distribution, as far as I understand it. I didn't like get too far into detail, like the actual source, but I thought the project was super interesting. So maybe if some of you are interested, I think it's very well worth checking out, especially if you worry about composition and doing, you know, control planes, right? I guess because I was always like with these tools like crossplane and so on, I was always a bit like it's always a bit special case. It's always a bit like a special model, and it's not too Kubernetes native. And they try to kind of do it in a native way, which is I thought was very neat or very lean, so to say. But I guess it's also about taste. But, yeah.
Cool.
I have to pick that one up. So who uses crossplane here? All right. How do you solve, because when I compared those two, how do you enable in your stack, how do you solve the issue with knowing the changes that will be done, which Terraform provides out of the box, and having the quality assurance using crossplane? So how did you solve this?
Well, I'm pretty sure that I don't, right? So that's why I'm not happy with the whole structure of it.
Okay, I see.
But the key, I guess we were going to a very deep discussion if we're talking about the data computations there, because I think you could still compose your infrastructure in like a more granular way, where you would use crossplane to kind of compose itself more. So you kind of like have that tree. Let's say if you use GitOps, you could like potentially argue you would have data computation, or you would compute the change in desired state in a merge request, for example, or a pull request, right? Where you could argue, well, it doesn't, it's the actual state, like Terraform would compute it, right? It doesn't matter in the end because controllers would have to take the right decisions eventually, right? You don't have to worry about it, and your kind of delta change would only be in Git. But I mean, it would, right now it takes a very apt, I would say, cloud native or like infrastructure engineer, automation engineer to understand the severity of certain resources. And
Is the big issue with crossplay not the vendor locking with the kind of very, I would say, ring-fenced resources, which are, you know, not really kind of understandable by someone like them?
Well, I mean, I think they do provide, in the end, the claims that they use are standard custom resources, right, in Kubernetes, but they abstract their own composite resources underneath them that actually kind of do the work. So you can kind of do most of the work on the claims, but yeah, the composition then in the end, if you don't use the in development or beta Kubernetes provider that they have to like scaffold other Kubernetes objects, I think it's you have to kind of stick with their resources, and I mean, if you're fine with having that kind of structure in your resource, then it's,
I mean, that's also the USP, right? That they say that you can stay in our kind of kingdom, and it also adds security for the engineers in the end, right?
All right. Thanks a lot, everyone, for this. This was open news. Yes, it's already finished. 15 minutes. That was it.
This is a news deep dive.
Yeah. And I have a great image for every one of you who didn't think of going to Amsterdam yet. Let's go. Come on. Next year. I think it's in April. But just look it up. Kubernetes Con.
Do you know which KubeCon this actually is?
No, honestly, I do not. But if you write to CNCF, they perhaps will answer. Oh, you know it. Nice.
I don't know it, but I think.
You think, okay. And that's it. Let's go to our main topic today, driving developers' experience with Kubernetes operators. The stage is all yours. We just need a second of switching microphones.
Presentation, our talk, actually our discussion also a little bit about Kubernetes operators. I think everybody, or most of you probably know about Kubernetes operators, but I really like to try to focus a little bit more on the aspect of how we try to drive developer experiences, Kubernetes operators. And I think that's a topic which not so many people talk about, so I'm really looking forward also to your feedback and to your experience on this. But first things first, who are we? I'm David Leitner. I'm working as a coding architect for Austrian company called SQUER Solutions. I do all this stuff around cloud native engineering, from infrastructure to software architecture, and I'm happy to always share my experiences. That's why I do it today again, together with my colleague Martin.
Hi, my name is Martin Fuchsluger. I'm leading the integration platform team at REWE Austria. So we basically provide Kafka for developers as a shared infrastructure that they can integrate the services together. Integration platform is supposed to be more than just asynchronous communication, but that's the focus. That's where we start. That's where we are at the moment. That we started with the Kafka 1.5 to 2 years ago and installed it on VMs. Asked our developers to send us an email if they need a new topic, and then we sent them a JKS file with a password on a different channel that they have credentials. And later on, we gave them a shared repository where they can add their requests there in a Terraform. And it worked. It worked it worked earlier in service desks where you filled out some forms, but it was not as fast, as smooth as we wanted. So we started with David and for my Ralph as a former colleague. We thought, well, what can we do? Well, how can we do it better? And what we found out is that our colleagues are working on Kubernetes. They have GitOps connected to this Kubernetes cluster as their new deployment for the new stack. And so we wanted to integrate and looked for some different ways. And we started the journey. We did not finish the journey, but will you ever finish such an operator? So it will be an everlasting project and will evolve over the time. And David and me are here now to present you a little bit what we thought, where we are, and why we did that.
Cool. Let's do this. Yeah. Who knows Kubernetes operators here? Who knows the concept? Okay. Not everyone. So I would say half of the people. Very short intro to Kubernetes operators, right? Everybody knows Kubernetes, I guess, right? Kubernetes is kind of an API server which kind of gets custom resources. These custom resources are different things. I guess most of you who ever worked with Kubernetes know pods and deployments. These are all custom resources which you send usually via kube control against an API. And this API then stores them in a persistence. And so we can, for example, take these custom resources and put them into the Kubernetes persistence. And then we have a set of controllers, and these controllers are picking up these custom resources and applying them against system resources. So again, for example, containers, in most cases, multiple containers, volumes, IP tables, you know all this stuff, right? And we have, of course, multiple controllers, and what they do is they kind of reconcile this all the time to check, is what we have in our persistence defined as custom resources still valid? Is this still reflected there? So there's this reconcile loop which never ends and which always ensures that what you ever send to the Kubernetes API to be presented on the Kubernetes cluster is also presented or available. And the interesting thing is that you can extend this custom resource. That's what was already mentioned in the news. You can create custom resource definitions. They are on their own, again, custom resources, which is kind of meta. And then when you define those custom resources, you can send those custom resource definitions or those custom resources based on custom resource definitions against the API. This, for example, could be a microservice. Microservice then does some things in the Kubernetes cluster. Or this could be a PostgreSDB. This could be a custom resource, and you say you send a PostgreSDB against the Kubernetes API, and then Kubernetes ensures that this PostgreSDB is started up. And what has this all to do with operators? Well, if you think about this, a microservice consists of millions, or at least couple of resources you usually need, right? Like deployment services, a Kafka topic we mentioned, IP tables, SQL tables, or classically Postgres tables, whatever. And usually you have a person which takes care that all these things are running all the time while you or the engineers can develop this microservice. And that's why I like the term operators, because it reflects quite nicely to what the operator in Kubernetes then actually is. We want to automate this process. We want to automate this operation process by saying, we can deploy, for example, this microservice custom resource against our API, and then we deploy a specific operator, which is kind of a service, we'll see it later, into our Kubernetes service, and then can pick up, for example, our definition of a microservice custom resource, and then creates multiple resources within our system. And that's basically it. And this operator then, for example, could also go to the outside. If we don't have Kafka running in Kubernetes, it could also go there and, for example, create a topic which we define as one of our resources or as one of our definitions in our microservice, or could create a table on Postgres. Well, with all this said, I would like to show you some existing use cases of operators. And basically, there are quite a lot. If you are not familiar with this, there's an operator hub where you find basically all operators which are publicly available. And you find a lot of operators, like, for example, if you search for Postgres, you, of course, find a lot of operators that allow you to run Postgres within a Kubernetes. We can discuss later if it's a good choice or not. Or, for example, Shrimpsy, the most popular Kafka operator, or, for example, Keycloak. I guess everybody knows Keycloak. Huh? Perfect. So if you, for example, go to the Keycloak operator here, then you see exactly what I told you. You see all these custom resource definitions there. So, for example, if you want to spin up a Keycloak now in Kubernetes, you just apply this custom resource against your Kubernetes API, and the operator will pick it up and will ensure that you have a keylog running, and the same goes for Kubernetes users and all the other things. So operators clear for everyone? Okay, perfect. Because that's a important foundation for what we are talking about now. So as I mentioned, most operators out there are infrastructure operators. I think this is not an official term, we just made this up for the presentation. But what we mean by this is that these operators are there to spin up specific infrastructure in our Kubernetes that Kubernetes does not officially support. But the talk of, or the topic of this presentation is how to drive developer experiences Kubernetes operators, as I mentioned before, and especially via pool-based continuous delivery or deployment. And that's the second very important ingredient which we need as a foundation to give you a better understanding what we're doing with this operator. So does everybody know about GitOps? I assume everybody knows the term, but we could discuss now for hours what it actually means. That's why I usually try to avoid it and talk about this idea of having pool-based CD, because very short story on this front. Usually you have, let's stick with microservices. Everybody's building microservices these days. These microservices consist of application code and infrastructure code if you're lucky. So if you already have infrastructure as code, like for example in Terraform or Ansible, then we traditionally took this and just, put it on a Jenkins, and the Jenkins was building the stuff, was deploying the stuff and all the stuff, right? We found out very, very soon that even if CI/CD is often used together, is two total different things. And I think most companies these days have the maturity to split this up and consider application codes to be continuously integrated, to be built. So we kind of create this artifact with a specific version. And what we then do is we, for example, apply this version on the infrastructure as a code. And then we have a dedicated CD pipeline, for example, Spinnaker, which takes this and applies this, for example, against our Kubernetes cluster. That's what was shown before. The problem with CD in general here is very often that we have a drift. And that's also important for the later topics of this presentation. And drift means that we have something running which doesn't reflect anymore what we have on the left-hand side as infrastructure as a code. And this drift can be created by multiple things, by technical means, or because somebody did manually something. So we actually want to avoid this drift, and usually we did, for example, just reschedules the kind of checking or applying of Terraforms against those Kubernetes clusters, for example. Another strategy against this drift is what I mentioned before, is to just change the direction of the error. This is usually what people do these days by Argo CD, for example, where we have this pool-based CD, where we go against the repository, and every time something changes on our cluster or in a repository, we kind of try to fetch the latest information, try to bring it in sync again. Exactly. So Argo CD, for those who don't know it, basically is nothing else than taking those custom resources, for example, as infrastructure as a code, and puts them into Kubernetes persistence. And this, in theory, reduces the drift. So let's put all this together. And there I'd like to hand over to Martin again. So let's put together custom resource definition, which I explained here, operators, and Argo CD. And let's show how this works in our use case.
Oh, thank you. Yeah, as David explained all these bits and pieces, we have to think how helps us in our use case, how helps this our developers. We created our own CRs, our own CODs, our own operator. That's maybe something to explain, and we already had to explain that a few times, so why do not just take one of the ready ones? We just saw the Strimsy available. We will see then a little bit later on what was the big use cases and reasons for that. But for now, we created our own CODs as our interface against our infrastructure, in our case. We have a short example of this. So it's one of our topic requests You see in the API version, it's our namespace. We see on the metadata one of our topic names. So, you know, we are an enterprise. It means we have a long and complex naming strategy. And later on, we see that we need some ACLs as specs. So who is allowed to read and write? What is the deletion policy? The official one deletion policy? What is the number of partitions and replications? So just some basic Kafka configuration parameters you need. And then, I mean, sorry, here we have the config cleanup policy. The deletion policy is now something special. That's not in the default Kafka operator. That's something we created because we trust developers that they know what they are doing and they don't have bugs. So we expect that the web developers delete just a CRD by accident, and we have to restore the data afterwards. So that's why we don't delete a topic immediately and give that some days as retention before we really delete the data from the Kafka, because that might be
it might maybe also be a bug in the operator, right? That the operator
might also be some bugs. But really then afterwards to restore some data in Kafka, that could be a nightmare. So that's why we added here some custom features for us.
Just one question. But
yeah.
So, the retention period is still 7 days for everybody, so that's not nothing you would overhead to the developer to decide.
No, you can change this.
We have a default, the default retention on our side. If they delete a topic, then because of the naming strategy, it should not be immediately be recreated like a test topic. But there is the possibility to override that feature for a developer if he really thinks he knows what he's doing. Then
no, but the question was different. The question was the retention time of Kafka, right? Which is by default 7 days. And you can configure this here. Under config, you can just change retention time to 2 weeks.
Sorry,
yeah,
okay.
That was the question. This is now limited to this config.
No. You have around 35 configuration parameters. You can, but you're right, we can control them. So we can, for example, say not more than 32 partitions. Doesn't make sense. Yeah.
So no, we can change all typically parameters of the Kafka topic. We have some defaults implicit there, but we also limit some factors for validation or for limits, or even don't allow some special parameters to be set. The second thing is quite easy. We have the Argo CD who picks up this manifests and CR from the infrastructure as code repository. So each product team has one repository with their infrastructure as code definitions, spots, deployments, everything they have. And within that, they create the custom resources for the Kafka topic. So then this ends up in the Kubernetes. And then our operator kicks in, he observes this, and then creates the topics, the users, whatever they request from us. How did we do that? We just recognized before, David is a fan of Rust development. I come from infrastructure part. I'm a Python developer. Ralph at that time was very Go.
Yeah.
And some others will have a very good Java background. So we had a long discussion what to use, which language, which tool set. At the end, we went to what, at least I thought, at the end, to go with the operator framework and with Go as a language. That looks for us to be at the moment one of the commonly used and one of the biggest frameworks.
Cool.
Then
so I would shortly demonstrate this, just to be sure. So I will also show the operator shortly. It was a longer journey to decide ultimately that it is Go and the operator framework. But let's start with a simple demo. So I really prepared something really simple, to be very honest with you. This is a simple repository, which basically consists right now of a test topic and the customization. And what we could do now is we could create another topic, basically based on the configuration we just saw before. So we give it a name, let's call it Cloud Native also. And we can set, for example, the cleanup policy. We could also change the retention time, but I don't know the config parameter now by default. We can change partitions and replications, and we don't have RTLs right now. So basically, I think that's it. Yeah, the kind is important, the topic and the name of the custom resource then also gets the name of the topic. We need to add this to customize, I think, otherwise it will not work. Quickly do this. So let's commit this. That's cloud native topic. Now we need to be quick. Let me check if I have everything prepared correctly. So we need to go to Argo, because here we already see that, you know, this project here, this David test project with a simple topic here, should now kind of switch to have two topics at the moment when we more or less push this. So let me do this. Yeah, directly to master, sure. So let's refresh. I really hope that this works now. Oh. Nice. Yeah. Come on. David tests. It's not here yet. Check. Ah, it's here. So this was just the latency of Argo CD, not the latency of the operator, just to be 100% sure. We see that this was basically created now. Yeah, we saw it shortly in pending state. So it went against our Kafka, which is currently running in Ivan. Ivan is a provider for managed Kafka. If I write here native now, I should basically find it, hopefully. It is partitions 1, replications 3, basically all what we just configured in the custom resource with the cleanup policy delete. Yeah, that's the really very short the really very short workflow a developer needs to do. It needs to create a custom resource in a topic, needs to push it, and basically that's it. And Argo CD picks it up and then sends it against the Kubernetes APIs. Maybe really, really short how this Go code looks like. I have the feeling people are often afraid of Go, but it's a wonderful language. It's basically one of the most simple languages you could probably think of. Yeah, exactly. But this makes it beautiful, right? You see here, I mean, it's hard to explain this now in a few minutes, but in the end, that's what you implement, this reconcile loop, which I mentioned before. So every time a custom resource changes, you get this callback, and then you can do stuff on this. Yeah. So for example, here we create topics and we delete them and so on and so forth. So we basically just implement the workflow which such a topic could have. And if it's, you know, not existing anymore, then it's get deleted. If it's created, then it's get created. If it's updated, then it's getting updated. I think that's clear. Good. Let me jump back to those slides. It was a little bit boring because it kind of worked. Yeah, that's the way how we roll. You see, that's basically what happened. And as I mentioned before, we just configure this custom resource here in the repo. Argo CD picks it up, and the operator then kind of takes it from ECD and applies it. In this case, for example, against an external API. And that's already an interesting use case for you, Martin.
To explain in detail. That's what I promised before. I want to explain it a little bit more why we did our custom operator, our custom resource definitions. We started also to look into the Strimsy. That's actually where we started with the operator. And you see that at the end, these operators from the infrastructure perspective are very much focused on being in one cluster. So that means first the infrastructure itself. So it's cool to set up a Kafka cluster, but then it's that the whole Strimsy expects that all the resources are in the same. There are possibilities just to use a part of this. If you just go to the entity operator, it's possible to ask another Kafka cluster, but it's not what it feels like when you start with it. The second thing is if you want to go to a non-clustered resource. That's what we do with the Ivan. The Ivan has their own operator for sure. We could use this.
We saw it even, right? We saw it even here in the operator frame.
Yeah, we saw it that there is the Ivan operator also available, but it also does not feel that let's say native way. If you want to just add a part of this, because to avoid that somebody then spins up a whole Kafka cluster at the back end, because if I don't want to give the developers the possibility that everybody starts his own Kafka cluster, I just want to give him the possibility to create a topic or the user, especially in this. And then our next problem was, let's go first to one thing, because now let's David open it. You know where it is.
Okay.
So this non-Kubernetes resource way, it was something that we discussed and thought, is this the right way? Because it doesn't feel that native. The tech rather gives us the hint that
it's actually a pattern, right? We invented without knowing it. I mean, we didn't invent it, but
no, we didn't invent it. We used it, and then we got the confirmation from the tech rather that we are not the only one who thinks in that way, and that there is already a pattern, and that it seems to be a valid solution for this what we wanted to.
Still quite new. It's still in assets, right? So people do not know that it's probably the right thing. We already know it.
I'm fully convinced. So this non-clustered resource was one of the ideas. The second was we have multiple Kubernetes clusters in our environment. So we are not just running in one cluster. We have a multi-cloud, multi-cluster approach. So depending on where we are, we end up with a few different Kubernetes clusters for different use cases of our developers. And that also makes it a little bit complex if you go with this standard operators, because the thing, it's one cluster, there is, my backend is here, and here are the topics, and everything is okay and good to go. And that might bring some duplicates that developers maybe, or somebody maybe requests or a topic which is already created in another cluster. So we have to think about how can we avoid this, especially if somebody then tries to catch an existing topic with his ACLs. And if you look to these default operators, ACL is their own entity, where you just can create an ACL rule for yourself. And that's something we want to avoid, because we don't want that each user or each team can choose their permissions. But the topic owner should provide these permissions to others if another team is allowed to read or write. And that's things that's not in the default one. And that's one of the first use cases here where we wanted to start, to have this Ivan and to have multi-cluster approach. And I already took the next one, I think. Are we there? Yeah, same story. Another basic idea is here to abstract our infrastructure away. And that means we started with the Strimsy one. Then we did our deployment on VMs and did our own deployment there because we didn't have Kubernetes ready at that time to use Strimsy really for our productive Kafka. And then we chose Ivan. And all this is possible behind the operator because we have one definition for the user. He requests his topic and he don't have really to care where his topic resides. And we have on one hand the API call that we can do against the Ivan API interface. We have on the second hand the Kafka admin client implemented. And we could also go the way to say, okay, let's move back to Strimsy. So we just transform our definition into an original Strimsy topic definition, or multiple ones to use the ACL topic definition also in the background and transform it this way and give a, let's say, hopefully more stable API to our developers.
Yeah, I mean, you talk later about mutation endpoints, so I think that also interludes with this. One interesting use cases with this extendability. So Martin already mentioned that it's kind of very important that you get these contracts right, of course. But if you get them right, you can do a lot with them because you basically own them. And an interesting use case is this migration scenario of resources, for example, of a Kafka topic. So it was already mentioned, we are always looking a little bit in Strimsy. We are, I think, Kubernetes fanboys from this direction, and we find Strimsy a cool project. But yeah, it's persistence, and persistence in Kubernetes is always kind of tricky. But maybe at some point in time, we want to migrate over back to Strimsy again, right? So we want to kind of take this stuff to Strimsy. And the interesting part is that usually the hard part between migrating from one Kafka to a Kafka is not to have the topic definitions there and there, but of course to shift over all the data. And one scenario how this could look like, for example, is that you extend this custom resource definition, which we shown before, and that you introduce something like mirrors into your Kafka topic, where you say, you know, we have the Kafka topic living in Strimsy and we have it on Ivan. And whenever you define such a mirror in the topic definition, we spin up a mirror maker for you. So we spin up a mirror maker which takes the data from one Kafka to another one, and then we define what is the primary one. And based on this, we can, for example, reduce the read and write ACL so that people cannot write anymore where it's not synced and the other way around, which is, for me personally, a quite interesting concept in this whole area of custom resources, that you also kind of interlude these migration scenarios like an operator would do. Like in the example in the beginning, an operator would take the data from one cluster to another one. Why should this not be able by operator written in Go? And yeah, if we then, for example, would remove these mirrors at some point in time, we would of course again spin down the mirror maker 2 and so on and so forth. And at some point in time, we would just, you know, remove the whole RCLs from the cluster before, so that we kind of have this transition very smooth and step by step. Another use case are custom validations. Martin, again on you.
Yeah, as I showed before the example, we have a strong naming strategy. And in this shared Terraform repo, it was always on us to exactly count there are enough dots in between and is a special field in the valid list of the values. And that's just one example of what you can do wrong or right in such a request. And here it helps that we can use the validation services Kubernetes provides. So it's not basically a feature of our operator, but it's feature of how we use it, that we can do some admissive or
validation
webhooks to, yeah, here's my specialist for the technical terms, So where we can do these validation services and see if the request is correct or if something is wrong. And yeah, the mutation service, we don't have a usage for that now, but we see it maybe in the future if we are transforming or evolving our schemas of the manifests of our CRDs, that it might help to transform that in the future.
Yeah, we will talk about the breaking changes and stuff a little bit later, but this is for us a use case where we say that we can keep custom resources backward and forward compatible by mutating them before they get into our cluster. Yeah, what I already mentioned before is this migration, and I'm a big fan of building workflows around these custom resources. And the really last use case I would like to show you, just that you get a little bit of an insight what you can ultimately do if you went down this road of custom resource definitions. Is again this topic of an operator, which is, for example, creating Kafka resources. These Kafka resources are then not only Kafka topics and RTLs, but probably also Kafka users. So those who are allowed to, for example, go against the Ivan cluster. So our operator creates Kafka users and Kafka topics and sends them against Ivan. And Ivan actually returns us a secret, right, for the user. So an access token, basically, a little bit more complex, but think just of a secret. And what would we do now with the secret? I mean, we could kind of set it to the status of the custom resource. It's not really nice, right? That's why, for example, you need to think, what would the operator now do? It would take the secret and would probably send it to you by email. Probably not. It would probably set it into some kind of vault. And that's exactly what we can also do. We get back the secret, put it into a HashiCorp Vault, for example, make it available. So even set on vaults the possibility that the one application which created this user can also only kind of fetch the secret. And that's things which you can easily achieve once you are there, because you abstracted this all the way. Yeah, the user just tells, I want the user, and I expect ultimately my secret in the vault. And it doesn't matter which secret this is, where it's coming from, who creates the secret, and so on and so forth. So this was kind of our last use case, and we could talk, I think, for hours about different possibilities how to utilize Kubernetes operators for driving developer experience. And I think it's not just Kubernetes operators, it's this whole idea of building up developer experience up on custom resource definitions, what we also discussed in the news already. And I think it brings, in a nutshell, to summarize this up, 3 main advantages. The first one is that you can craft vendor-independent definitions, contracts, APIs, however you want to call them, for your infrastructure. So you're not dependent on what Shrimsy defines as a Kafka topic, or what Ivan or what Confluent defines as a Kafka topic. You can craft this based on the context of your company, right? I think it strongly depends how a microservice looks like, because again, Conway's law, maybe your microservice look differently than those from other companies. Maybe your microservices always, I don't know, need to have a Kafka topic, or always asynchronous law, what. So you can really go to developers and ask them, hey, what do you expect? What does a microservice actually mean in our company? And can already provide some nice bootstrapping for them. The second thing is that you can actually, what I try to stress with my 2 use cases, build these workflows, these extensions, and you can even kind of enforce migrations by going down this road, which is, I think, a very interesting idea or concept. And last but not least, we can really do validations against these infrastructure changes. So, of course, custom resource definitions are open APIs. So you can, of course, already there make some definitions and say, I don't know, you're not allowed to create more than 25 partitions. But when it gets really tricky, then this webhook extension of Kubernetes comes really handy, because you can validate, is this set and this set, then it should not work. That's something you cannot really achieve by an open API spec. So these are the main advantages in a very generic way to explain them. But we also want to be very honest with you. And I think there's a lot of challenges you also, of course, kind of earn when you go down this road. And First of all, breaking changes in schema evolution. That's something which always breaks our hearts. Doesn't matter if it's a custom resource, it's an API, or if it's a Kafka topic. You always need to kind of do a little bit of front design, and I know that's a bad term these days, but to really understand what is the resource, because once you locked it in, once teams are live with this resource, it's really hard to change. And you can work with this mutation webhooks and stuff like this. But schema evolution in general and custom resource definitions is a kind of very, I would say, unsolid area these days still. It got better. We have versioning and all these things, but there's not so many best practices people talk about and share their experiences with. Race conditions, that's something you need to be aware of. So it doesn't mean that whenever you send a custom resource against the API, it's synchronously picked up, and infrastructure creation is not always synchronous. So there's a lot of asynchronity in this whole idea of building operators, and there's a lot of potential for race conditions. For example, somebody already creates a ACL for a Kafka topic, but the Kafka topic was not created yet because it took 2 seconds later to create a topic than the ECL. So that's something I think which brings a lot of complexity, where you need to really test a lot. And this brings us already then to another bottom line of operators. But before we talk about testing, let's talk about security, because that's always a concern. This operator needs a lot of permissions in your Kubernetes cluster. So it needs to listen to probably all namespaces, right? It needs to kind of modify them in some cases. It needs to register custom resource definitions. So it's really hard to find the good fence in which this operator is allowed to work. But something solvable, but something you really need to be aware of. You really need to understand a little bit the internals of Kubernetes security mechanism. And last but not least, the stability. I think that's something which is not that mature. Operator framework comes with a few nice tools, but you kind of need to consider this upfront. Like in good software engineering, you need to build this operator in a way that you can test it. Best with unit tests, but you also kind of need integration tests for this operator, right? So there's a lot of stuff you need to invest to really validate that it is working, because if it's not working, then it's usually painful. That's it. So consider twice if you really need them. I think that's the most important message of this presentation, unfortunately. Yeah, we are happy that we went down this road a few years ago, but you should really consider twice if this complexity and effort really pays off. And that's something I know which is always hard to understand for us as software engineers, but we really need to understand the trade-off we're doing here. So consider twice if you really need them. Yeah. That's it. I hope this was useful. We hope this was useful. We are around now. I guess everybody is around for just another while. We like to drink beer and wine. So if you want to discuss anything which we said, if you want to share your experience, I'm really happy to hear them. Thanks a lot.
Should we ask the internet if there are questions?
Let's check the chats. On the chat, there's nothing right now. No. Any questions from the audience? Yeah.
When you presented like the topic custom resource definition, it felt like a little bit shifting the data plane of an application to custom resource definitions. Is there like a point where you say, okay, do this, but don't do that, or?
Of shifting a data plane.
Yeah, basically you shift like the data plane of Kafka, which is like topics,
yeah,
to the custom resource definition.
Yeah, exactly. I think that's the point which I mentioned before, that most operators are not doing this, or not exclusively doing this. I mean, Streams operator also has definitions for topics, but we are exclusively doing this. We don't spin up infrastructure. We don't spin up a Kafka cluster, right? But we just kind of, manage the metadata of those infrastructures.
Also with this approach, you have to like give developers access to the API server, I guess, because they can deploy topics with this approach.
Not really. I mean, we have, as I mentioned, there's a whole application platform running in the background, which does more or less this kind of Argo CT integration. So whenever you have this customer, as you've seen in the repo, I didn't apply anything anywhere. This is a kind of a repo without even a CI/CD pipeline. It just kind of sends a webhook whenever a commit changes. So from their perspective, that's not a security problem.
Yeah, Yeah, the main disadvantages I see is like different operators interfering with each other, probably.
Yeah, that's also race conditions. Yeah, you cannot really guarantee the order. For example, we could also consume native resources like, I don't know, a pod, right? But we never know who does what first, right? And I think often people do things in operators which they should do in mutation webhooks. So usually you want to avoid in the beginning already that you need to extend the resource and stuff like this later on, but you should already do this before it even enters your Kubernetes persistence.
I mean, there is though a couple of, at least the operator framework they mentioned though, quite specifically, like a common case I think in the beginning was people augmenting an existing resource with another operator, saying, okay, I need more functionality, I'm going to put this on top of it, right? And they specifically the operator framework I think mentions it quite strongly. There should be always a specific controller dealing with a specific resource, exactly. Right? You shouldn't really have multiple controllers operating on the same resource, for example. So at least you have some kind of idea that, well, if this type is kind of like, I should have a distinct functionality and not really interfere with other things. But of course, sometimes you have to, right? Like you mentioned it, potentially you could augment or like put that, like the operator that you produced on top of Springsy, right? But you would have to make sure, well, okay, I need to check that Springsy did everything that they had to do, and now I can do things, right? So,
yeah, but this would you would. I mean, I think that's a very good point. And if you would ask me for one anti-pattern, that's actually it. Yeah, if you have a resource, one operator should listen to it. And if you really have this need that you kind of need to implement these workflows, then it's probably better if you kind of produce another custom resource, right? So if you say, you know, I did this step now I create this custom resource, and somebody else again listens to this custom resource. You know what I mean? So stuff like this. That's, I think, what
exactly. So you would just then say, well, I put something that refers to an existing custom resource rather than just react on top of that process, for example, exactly. That instruction really. But we have to acknowledge as well, definitely when you go down, I think maybe that's another challenge, right? You are forced to do a lot of very defensive coding, right? Which in general is something maybe not like something that you should maybe strive to, at least in my opinion, right? I guess there's very many opinions in the room, right? But a lot of course, defensive programming is always time intensive and consuming, right? So and I guess that's also something that I think it adheres exactly to what you said. You should think twice about what you really need them, because if you don't have the people who already know how you kind of approach this, and kind of like the patterns that you would have to implement to safely kind of do things, you will run into a lot of issues and you discover these kind of things, and that means basically you are forced to be very safe, and it will cost time to do so, right? So you should definitely consider whether it's the right thing.
Exactly. Yeah, it's a trade-off. So it's not a silver bullet. It's unfortunately a trade-off. Yeah.
And I think the case that I think also like on top of that is a very good example of why you could do it, for example, why you should do it is specifically, and I think you mentioned it, right, like it's about driving developer experience, right? But driving developer experience eventually, at least in my opinion, means that you also kind of like let people actually contribute stuff in the end. It's about scalability as well, right? You don't want people to just necessarily be blocked by you having to implement another automation part for someone, but then to eventually, as long as people grow understanding these mechanisms, like you look into how this works more and more, you can like open it up gradually. It's literally the same as you would develop a microservice. Like an operator isn't really that much different, rather than just a smaller service like unit.
Yeah, that's also a thing, like you're moving from a containerized, like in a secure context pod, for example, into an operator with just like a lot of access to everything.
Right. I mean, it is a pod eventually, in most cases, running in your infrastructure, but it has a lot of capabilities, right? So, but yeah, like you could slowly at least leave people in terms of like you can augment your own experience on top of that. If you want your own resource, if it's just translating the one thing to another, it's a very limited set of permissions then, right? You can say, well, we offer you this bigger one, or like this kind of experience. If you want to change it, you can let people transform it or augment it or in their own kind of way.
Yeah, we had in the whole process a few discussions what the operator is allowed to and what not. So you could also limit it to special namespaces like Streamset does per default. But if you have then at the end, let's say 90% of the applications in the Kubernetes using Kafka, does it make sense to operate all this, let's say, onboarding process that the namespace will be monitored and having all this list maintained? Is it worth for 10%? Yes or no? You have to decide at the end. We had, instead of the vault, the discussion, should we write back the secret as a Kubernetes secret into the namespace of the application? No, we don't want to have write permissions into another namespace. So on the whole process, you have a lot of things you have to think about. Yeah, for sure.
Exactly. I think that's an interesting question. If you could go this road down of having an operator more granular, multiple of them, but for specific namespaces, also in terms of blast radius when something is not working, or when some custom resource breaks the operator for whatever reason. That's not what is here right now. But I think, yeah, step by step, problem by problem, and I think that's the road we're going down.
Yeah, it's a similar thing. Yeah, as I said, we did Terraform before for managing the topics, the requests, and then you have the same problem. Want to have a shared repository there, and somehow share what the different applications can see and how they can act. And then you always need a team as a tiebreaker or somebody who monitors against violences, let's say it that way. Or do I want to give each team their own Terraform, and then you have to create the logic and have to spread them over their teams that they can implement it in their CI/CD pipeline, and if something changes, how you get back the logic change into all the single Terraform runs. That's where we, for us, at the end decided that the operator way is for us the better one to go.
Yeah, I think this validation webhooks are underestimated, because in comparison to Terraforms or Blumner or whatever, it's really nice because you can really validate what is happening, right? And you can give the developer the freedom to do everything, but they can even check it in and put it in their repo, but it never lands in Kubernetes if it doesn't fulfill some specific validations. And the second thing on what you mentioned is, I think, kind of also interesting with this idea of having the operators limited by namespaces. You could even do a meta custom resource, right, which gives then the operator access to a namespace, and you have an operator which just gives operators access to namespace and stuff like this. So if you think about it, you end there. Oh, yeah. Any further questions? Yeah. It was just.
How does the developer experience for the operator developers look like? In the challenges we had before, sounded a bit scary as a developer. Can't be tested, race conditions, security is very difficult.
I think it's not that it can't be tested. I think, you never usually test, I don't know, Terraform scripts, right? Terraform definitions. You just put them there and see if they're working, right? But that's a little bit different here. You really do software engineering, classical, good old software engineering, right? Where you really build, as mentioned before, it's not really microservice, but it feels like this, right? You build this stuff in Go, which is running in Kubernetes, which gets requests. These requests are from Kubernetes, but it doesn't really matter if you build a controller or such a thing. And they, of course, need experience how to write code that it's testable, that you don't need to test everything if you spin up a whole Kubernetes cluster and operator. So I think that's the first thing. And the second one is really the race conditions are hard to avoid. You need some kind of understanding of distributed systems. You need to have some understanding of asynchronous or event-driven systems, maybe that then I think the learning curve is not that steep. But if you worked in synchronously integrated monolith all the time, right? And it's hard to think in these patterns and think in this asynchronity. Yeah. But to really answer your question, the developer experience is quite good with the operator framework. Operator framework is not something high sophisticated from perspective what it does. What's sophisticated about this is the whole scaffolding. So it's kind of like a CLI where you say, hey, I want a new custom resource. It creates the YAML file for you. It creates the Go definition for you. It creates the controller for you. It kind of gives you this very, kind of CLI style of developing these days. Yeah.
In this specific project, you also said the schema versioning and changes is something that's not well handled, so a challenge. So how did you deal with changes of the operator, of new features you implemented, maybe features you changed?
Yeah, that's a good question, because so far we just say backward compatible, right? We just add fields, or we kind of keep them and say, hey, this is kind of deprecated now. This is, I think, the biggest challenge. There are different strategies how you jump from version 1 to version 2. But so far we were in the lucky situation that we didn't really need it. We're 100% sure that at some point in time we will need it, yeah. And then it really comes down to the same questions which you have on API design. Do you build a new API? Do you build a dedicated, service which deals with the new version? So version 1, version 2 on the API part, or do you kind of stay backward or forward compatible? Or, it's in the end the same discussion. Do we define a new custom resource? Do we define a new version? Do we try to just add new fields or remove optional ones? Yeah, that's basically, it's open API, so you have the same constraints like you would have for API development.
Maybe if you do encounter it as a tip, because there's quite a bit of a rabbit hole, I think, to it. I don't know who else did it here already, like doing the advancing versions on custom resources, but the operator framework is based on another framework called KubeBuilder, like just as mentioned here, and they mentioned this kind of hub-spoke principle of defining one version of a custom resource as kind of like the storage version, and all others are kind of just like still there or still served to the kind of interface with the resource. I'm not going to go into too much detail. That's available as resources. Just never kind of as a heads up or like a watch out, because I went down that road. Don't think of just because I raised the version of my custom resource definition, let's say I make it not V1 but V2, that it's somehow a separate custom resource. It's still the same object in the persistence. It just gets another version of how another schema kind of attached to it, right? Still, Kubernetes will still point to the same object. So it will not just like magically kind of save different fields. It will not be separate types, which I kind of like imagine it as like, okay, it is kind of like a full kind of new type then. It will not be, so you really have to deal with, well, in the previous version I stored fields X, Y, Z, in a new version they don't exist. How would I be able to retrieve them? Because if I ask kind of this new version, I won't get these fields, of course, right? Because the schema is different. So if you ever encounter it, just look into those guides. I think there's quite some lined out strategies. I don't think this documentation is great, but that heads up kind of like by another colleague at the time helped me a lot to kind of like understand it. And so, I really have to understand that I still need to be able to persist some fields for backwards compatibility and so on. So it's a bit about, you can kind of mark what is my storage resource and which kind of versions do I still serve, or which do I even disable or do not support anymore.
I think everybody working for Kubernetes more than half a year already had this situation when the V1, the Alpha 1 version was not available anymore. So,
yeah, but I think the point is very important that actually Kubernetes only stores one version, right? It doesn't store version 2 and version 1 of the same custom resource definition, different instances of it side by side. You need to understand what is the storage version, and then you need to provide transformations between those. Yeah. And that's something which is, I think, very complex, first of all, to understand how this internally really works. It's barely documented. And what you refer to is the KubeBuilder documentation. I think it's the best one you get for versioning custom resources right now. Yeah.
But the point is, like, when you do it, there is always this mention of the so-called group version kind, right? Which is the combination between the API version, like the tag you just saw, the version after the slash, and then your kind. And this is kind of, you kind of start treating this as your, oh, this is my unique identifier, this is the whole thing that identifies my type, really, right? It's a good type. I don't know, like string in my standard library or something, right? Or that version. But the point is, it's just mentioned everywhere, but it's actually not the type defining thing. It's just a group kind, and not the version is not defining kind. So it appears like it would be, and for me it was kind of like I always went down the wrong way of thinking, kind of, you know, having this always there, thing, you know, how just make a new type, so to say.
Yeah, fully agree. Cool. Any further questions? Everybody already looking forward for some beer and wine, and of course also everything else.
If not, thanks for joining. Thank you, everyone. Thank you.
Thank you very much.
Thanks.
See you. Ciao, ciao.
Thanks for being here.
Yeah, it was a great pleasure.